Hello and welcome to today's lessons. I am Emmanuel Ketiabuahen from Inclusive Tech Group, and I'll be taking you through today's lessons on accessibility with respect to human-computer interactions. In this lesson, we will learn something about human-computer interactions, something brief. We will learn what it is. We will also learn why we need to understand human-computer interaction. We will learn something on accessibility, what accessibility is. You learn why we need to consider accessibility. And we'll learn disabilities, some forms of disabilities. We'll learn something on assistive technologies. We'll learn something on universal design principles. And you will find out how we can test for accessibility on various platforms like the mobile apps and the web apps. So what is human-computer interactions? It is basically the study and practice of usability. Any system we develop, we want to make sure that it is easy for our end users to use. So the things we consider in order to make sure that such systems are easy to use is what is termed as human-computer interaction. It is also the study of how humans use computer systems to perform tasks. So you observe human behavior, then you observe your computer system you are building, then you find out how to create a very nice relationship between the humans and the computers so that at the end of the day, the humans can solve their problems with the computers efficiently. So it is safe to say that human-computer interactions is a blend of computer science, cognitive psychology, and fine arts. To use the computer science to develop the systems, then we use cognitive psychology to check on how humans perceive our system, how they understand our systems, what they think about the system that they are using to solve a problem. Then we use the fine arts to kind of design it a bit. So we blend all these in order to create a very suitable environment for our end users to use computers to solve problems efficiently, hence achieving human-computer interaction. So you can see that our nice lady here is trying to interact with the computer, and the computer is also giving the necessary feedback to the person. So whenever HCI is very effective and well used, there will be a very comfortable situation for our end users to solve the problems they want. So why do we need to consider HCI? First of all, it increases productivity for our end users. Any system we build, if we consider HCI in the development process, we will end up creating highly efficient systems which will help our end users to be very productive. If our systems are not that efficient, our end users will find problems trying to solve, trying to use our system, and it will reduce their productivity level. So HCI, considering HCI in our design process, can help us increase productivity for our end users. HCI also decreases user training and time cost. If our systems are easy to use and understand, you can easily train people about it. You can train people on it, and it also reduces the time you are going to use in training them. I have had a personal experience where we made sure the interface of the system we developed for a certain organization was easy to understand. So we had budgeted for a week training, but within 3 days, the people just understood, the workers just understood the system, and we only had to use an extra day to brush over. Then we had extra 2 days for free because everything went well. They understood the system and they were able to solve the problem they were trying to solve with the system. So the 2 days, the extra 2 days, we saved time. We used the time to do other things that we wanted to do, and also saved on hotel bills. So you can see if your system is efficient enough and the end users easily understand it, you don't spend too much time on user training. Also, it decreases user errors. Before your system goes out there, if you considered HCI, it will let you make sure that you accommodate for user errors. It will help you make sure that you build the system in such a way that you already perceive the possible errors that the end users will be causing and try to solve them before the system is even shipped out there. So by so doing, the error count becomes less and the system becomes friendly to the end user. It also increases the accuracy of data inputs and data interpretation. Assuming, let's say you built a web app and you expect people to enter their age. Age is an integer, but if your system is not built to be easily understood, someone would just try to type their age in test. Now, if your system is expecting an integer input and the person submits a test, your data interpretation may not go so well in your backend. So if you use HCI, it will cause you to consider things like validation, so that when the end user enters the wrong data, it can alert them that you have to enter an integer. By so doing, the end user begins to understand the system easily and they are able to perform the tasks they want to perform, and the data accuracy will also be assured. So another importance or another reason why you have to consider HCI is that it decreases the need for ongoing technical support. If the system you are developing isn't easily understandable, it is highly likely that your end users will keep calling you. Your phone cannot rest because for every simple task they want to perform, they will encounter a problem and try to reach out to you to help them. They'll call you and tell you, I clicked this, I was expecting that this will happen, but this didn't happen. So you'll be going back and forth on one system that you developed. But if you consider HCI, you account for all this before even the system is shipped out there. So it becomes easier for them to use. And your level of technical support, ongoing technical support, is reduced a bit. So you can use that time to do other things. So when doing HCI, some tips you have to have is you always have to consider three things. You have to understand your user profile, the person who is going to use the system. What is their understanding level on the system they are going to use? How do they perceive your system? How do they imagine solving the problem they are going to solve with your system? With this, you will know how to build a system to suit the end user. Also, the next thing you have to consider is the context. So context simply means circumstances forming a background of something that is occurring. So why are we developing this system? What was the circumstance that brought about the system? So if you consider the context, you always end up building a system which matches the problem at hand. The next thing you have to consider is the task. You always have to consider how your end users, the process through which your end users will be solving the exact problem for which you build the system. So when you consider the task process too, it will help you develop your system in such a way that it is friendly to your end users. And at the end of the day, it will create a very easy environment for your end users to operate on your system. So in HCI, one thing you have to consider is accessibility. Accessibility is simply an art of making systems usable to as many people as possible. In when we develop our systems, sometimes we do not get the opportunity to meet every user who is going to use our system. But if we develop it well enough, we can be rest assured that in the future, the new users of our system will find it easy to still use the system. One of the users of our systems could be someone with some form of disability. If our system was not designed with people with disability in mind, it becomes difficult for such a person to use it. So let's dive a bit deep into accessibility and understand how it relates to human-computer interaction and what we have to do to make sure that it is easy for them to use. So accessibility is also it can also be defined as the design of usable products, devices, services, and environment for persons with disability. So you are designing a product or service, and you are considering people with disability. So why do you have to consider accessibility? First of all, accessibility is the right thing to do. If you consider accessibility, that means you give other people who would not have had the opportunity to use your system, you give them the opportunity to actually use your system to perform tasks as well. Imagine sometimes, let's say, someone with a disability trying to use your system to solve a particular problem. If you imagine these things, it will cause you to understand how they are going to go through the processes through which they can actually achieve what they are looking for and cause you to design your system to accommodate them. So if you consider accessibility in HCI, it's actually the right thing to do. It makes life easier for persons with disability who are trying to use your system. Also, it is the legal thing to do. If you, for instance, in Ghana, we have the as a Persons with Disability Act 715, which was enacted in 2006, and it talks about how persons with disability should be treated in this country. In some countries, if you flout some of these rules, you could actually even experience a jail term for not considering persons with disability in designing your system could actually be an offense punishable by law. So it's also the legal thing to do when building systems. It gives your product or service access to a wider market. In Ghana alone, it is estimated that we have 5 million Ghanaians who suffer from various forms of disabilities. Now imagine that your system can be used by all these people, and all these people are now beginning to sign up on your system to use it. That means you have 5 million extra users just because you considered accessibility in your design process. But if your system is not so accessible to them, then you lose 5 million people who could have signed up on your system. So it becomes necessary that we consider accessibility in our design process. If your design fits persons with disabilities, the probability of easy use for everyone is very high. Most of the times when you visit buildings which has the ramps where we use the wheelchairs to climb up, you realize that people normally prefer using that section than the staircase because it's easy to walk on that one. The building was designed in such a way that it could accommodate persons who with mobility impairment, people who use wheelchairs. But even people who could walk, who can walk, actually prefer that side more than the staircase. So if you design your system in such a way that it accommodates persons with disabilities, it makes life even much more easier for the persons without disabilities who are using your system. And that drives more usage on your system. So considering accessibility is very necessary. So since we've mentioned accessibilities, we have to talk about disabilities. Disabilities is why we consider accessibility. So disability, according to the World Health Organization, is an umbrella term covering impairment, activity limitations, and participation restrictions. Anyone who wants to perform any activity but for one or two reasons cannot do it suffers from a kind of disability. For instance, if you can walk and you experience a muscle pull right now, and for that reason you cannot move your legs to walk, that becomes a mild form of disability known as mobility impairments because at that moment you cannot move. So disabilities actually, there are no special people who suffer from disability. Anybody can suffer from disability. And it is necessary that we understand these things and build systems which fits everyone during our design process to make life easier for anyone at all because anybody can move from not being disabled to become disabled in some few days. And people with disabilities, partial or mild forms of disabilities, may also be cured and will not become disabled. So disability doesn't have special people, and we always have to consider it during our design process. So there are five basic categories of disabilities. When I mention disabilities, we have people with visual impairments. This deals with people who have problems seeing, who cannot see at all. There are certain people who cannot even see colors. If you show them that this is yellow, this is blue, this is red, they will see it all as gray. They will see it all as one color, and they cannot tell the difference between the colors. So we have visual impairments. We also have cognitive disabilities. Cognitive disabilities has to do with people who have problems thinking. There are people who take time to process information. Like you can say something right now, everybody will understand it. But there are certain people, it will take them about a minute or two to process the information before they can understand you. There are people who experience things like dementia. They easily forget things. You tell them one thing right now, in the next 5 minutes, you ask them, and they're asking you, what are you talking about? That's a form of disability. We have hearing impairments. There are people who cannot hear what we say. They don't hear whatever is going on. They don't hear anything at all. There are people who can hear in one ear and not the other. So all such people are experiencing some form of hearing impairments. We also have speech impairments. We deal with people who cannot talk, people who cannot speak for whatever reason. And we have mobility impairments. Mobility impairments is self-explanatory. It means people who have hard time moving around, who cannot move around for one reason or the other. So just like I mentioned, there are 5 million Ghanaians estimated to have some form of disability, according to the Ghana Federation of Persons with Disabilities. And people with disability, such persons rely on something we call assistive technologies. Assistive technologies are simply is any hardware or software designed to help persons with disabilities. So if you design any hardware system like a wheelchair, you are helping somebody with disability, and that becomes like an assistive technology. If you design a software like the talkback feature on Android phones, where it reads the text on the screen back to the user, that is a form of assistive technology. So we will consider the various categories of disabilities and some assistive technologies they've been using to make their lives easier. First, let's consider uh, visually impaired people. Visually impaired people normally rely on voice recognition technologies or voice recognition programs. They, they, for instance, there are times where currently we have something we call Siri on iPhones, or people also use OK Google. You call OK Google, then you mention your command, then it performs it for you. You can actually make a call without touching your screen by simply saying, okay, Google, call Kwame. Then it starts placing the call. If someone is blind, the person will really need this feature because they won't have to struggle through their phone in order to find a particular contact to place a call quickly. You see, this was designed for persons with disability, but persons without disability are even enjoying it more. So such systems are known as assistive technologies, and it makes lives of persons with disability very easy. The next thing to consider is screen readers. Screen readers simply their software which runs in the background and it reads everything on the screen for persons with visual impairment. And we have the screen enlargement applications, which is like the Zoom tool. In Microsoft, we have the magnifier. The magnifier, you can see content very large, or you can reduce the magnification level. The next thing to consider is cognitive disabilities. As mentioned earlier, cognitive disabilities have to do with people who can't, who have hard time thinking or processing information, and, or people who have difficult time in remembering things or perceiving how things work. So parents with such disability normally rely on cognitive aids. They rely on cognitive aids, including computer or electrical assistive devices. Some of them have devices which alert them that it's time to do some particular tasks because they might have forgotten that they are supposed to do those tasks. And even people without disabilities rely on software like alarms, which alerts them that it's time for a specific activity. So All these things are systems known as assistive technologies, which is making the lives of such people easier. Such devices help people with cognitive disabilities on their memory, their attention span, and other challenges in their thinking skill. People with hearing impairments usually rely on hearing aids, and they also rely on captions. Their hearing aids is like currently what we call earbuds. Normally, that's how it looks like, and it amplifies whatever everybody says, and they can hear you now. That is for people who have hard hearing. And the closed captions, normally, if you watch videos, you see that there's a text appearing down there. Like I speak a specific sentence and it tries to write the sentence on the screen. Yes, people who cannot hear at all normally depend on the text on the screen. So that is what we call the closed captions, and it really helps them to understand what is being said on the screen. And the next thing to consider is speech impairment. With speech impairment, we have the text to speech engines. It helps people who cannot speak actually talk back to people. For instance, people with speech impairments can simply type what they want to say, press a button, and it talks back to the person they are trying to communicate with. And people with mobility impairments rely on wheelchairs, scooters, walkers, canes, crutches, and protective devices for mobility. So these assistive technologies makes the life of persons with disability very easy. And these assistive technologies are what such persons use to assess your system whenever they try to use it. So if you understand these assistive technologies and how it works, it helps you to develop systems which becomes easier for them to use, hence achieving the goals of human computer interaction. So when we talk about disabilities, we always have to talk about universal design principles. Universal design principles is simply a framework for design of living and working spaces and products benefiting the widest possible range of people in the widest range of situations without special or separate design. The thing is, when you develop systems, looking at all that we've said, you may be tempted to think that then we have to develop an extra system for persons with disability, a separate system altogether for persons with disability to use. But that comes with an extra cost, like the design cost and the time cost. But there is a principle known as the universal design principle, where you can design one system to be usable to all. This term universal design was coined by an architect known as Ronald Mace. So this universal design principle was broken down into 7 principles that if you follow during your design process, you will end up definitely achieving HCI, because at the end of the day, you build a system which fits as many people as possible. The first principle to consider is equitable use. Once you are designing your system, consider equitable use, which means make sure that you imagine all the possible people to use your system, and how they can equally use your system to perform the specific tasks they want to perform. The next principle has to do with flexibility in use. You must give people customization options. For instance, on your phone, you can customize how loud you want it to be. You can customize the backlight feature. Some people want their backlight to be very bright. Some people want it to be very dark. So with all these features, it becomes flexible for many people to use. The next thing to consider is a simple and intuitive use. You have to design your system in such a way that when anybody picks it up, they can actually imagine how it's going to be used. For instance, if you pick up a spoon, you realize that the food has to be in this section and I have to hold the spoon at the other end. You see, it becomes easy and intuitive. The moment you pick it up, you understand how it works. So when you design your system like that, it gives it a touch of universal design where plenty people can use your system to achieve the same task. The fourth principle has to do with perceptible information. When people open your system or pick up your system, they try to imagine certain kind of information. For instance, if you see a button on your screen labeled as start, the person will perceive that that is where they open the menu from because they've been seeing that on computers. But assuming they click on start and a video starts playing, it becomes a bit of a difficulty. They may not understand what is happening. But if people are able to perceive your system and actually perform a task based on their perception, it becomes easier for a lot of people to use your system. The next point has to do with tolerance and error. You always have to create room for errors when designing your system. You must create room for human error because we are not all the same. Somebody may pick up the system and understand it straightforward and just use it without any errors. Another person may find it very difficult to understand from the first start to the end, especially people with cognitive disabilities. So you have to create room for errors so that uh, they can learn through the errors little by little and become good at using your system to solve their problem. The next thing to consider is low physical effort. When you're designing your system, make sure that people don't require too much effort, too much physical effort to use it. For instance, if it's a bottle opener, people don't have to struggle on their way through your system to open a bottle. It should be very easy to use for everyone. The last thing has to do with size and space for approach use. This is simple. It means give enough space on your system for people to operate. Don't jam everything up in one in one region on your system. For instance, software system, don't put plenty things together on one page. Just give people enough space on the page to operate. And I think with this, as you perform all these tasks, all these seven principles, you end up achieving a universal design where a lot of people can actually use your system. So somebody will ask that we are developing computer systems. How can we possibly test these computer systems to know that they are accessible or not? For instance, we are developing mobile apps and we are developing web apps. How can we know that it is accessible or not? Well, first let's consider web applications. With web, if you want to know that it is accessible, you have to do manual testing. You yourself, you have to test the system with possible assistive technologies that you think your end users will use. You also have to do user testing. You have to make sure that your end users, you get one or two people from your end user collection or from your end users, you talk to one or two of them to try out your system and give you a feedback to know if your system is really accessible or not. You can also use test tools. Currently, people have developed tools to actually test your system for accessibility. And for web, some of the tools to use are HCI and Wave. These are the popular tools to use. We will try our hands on the Wave before this lesson ends. If you want to test accessibility on Android, same way you have to do manual testing yourself and you have to do user testing with actual users. Then you can use test tools like Accessibility Scanner. Accessibility Scanner is on Play Store. So you download Accessibility Scanner. I'll show you. Then when you install it on your phone, it will be running on the background. Then you open the app you have developed, which you want to test the accessibility. Then it will give you feedback that maybe your contrast is too low. You should make sure that the contrast is a bit higher. You should make sure that this image has an alt text and all those. For iOS, you have to do manual testing and user testing, or you can use the disability inspector on your debug app, on your simulator, iOS simulator. So I will take you to a site on iOS, on Apple, where you can actually follow certain procedures to test your apps for accessibility. So let's consider some accessibility tips. Then from them, you will do some tests, some actual practical tests on accessibility. First of all, if you want your system to be accessible, think user first instead of product first. Always think about your end users first, who they are, what they are going to be doing with your system, and their understanding of the system. Next, test the accessibility for your system yourself before rolling out. Test it out with available assistive technologies. Test it out with people, actual people, before you roll out to the entire world. Next, gather feedback from users on how accessible your system is. Like the second option is saying, as you are testing, make sure you test with humans and gather their feedback to know how your system is doing on the accessibility side. Also, know the assistive technologies or the assistive devices that your users will be using to access your system. By so doing, you can build a system which suits such assistive devices and to make the life of persons with disability easier. The next thing to consider is always be patient and communicate well with users with special needs. Users with special needs, when they start using your system, most of the time they're already frustrated because it becomes like another new learning curve for them. So if you're not patient with them, it becomes difficult for them to open up with their actual problems. But if your communication is effective and you are patient with them, they can actually tell you the problems they are facing and suggest to you certain things that you can do to help them. Thank you. So let's move on to certain practical tests that we can do to check accessibility. First of all, we will consider this. Yes. So let's first consider a test for web accessibility with a wave tool. For instance, we have a website. Let's choose one of the common websites like My Joy Online, which is a news portal. Imagine My Joy Online writing news for the entire Ghana. Let's see how accessible their system is for persons with disability, like people who cannot see. So first of all, let's check for Wave Accessibility Test Tool. When you Google this, you can see the Wave Accessibility Test Tool right here. So let's click on it. And when you visit the web website, you have a very simple page, and you just have to enter the address of the page you want to test here. So when you enter the address here, all you have to do is hit enter to start running some tests and give you feedback. So we want to check My Joy Online. Yes, we have My Joy Online here. Let's see what happens. So Wave is working on My Joy Online website. And let's see the results from My Joy Online website. Sometimes it takes a little while in order to gather the information we are trying to look for. Yes, so after we've tested My Joy Online, we can see that we have 74 errors on the page. That means we have 74 possible ways that persons with visual impairment or persons with disabilities accessing this website will encounter problems. We have about 26 contrast errors, and things we have to be alert on are about 81. So let's check out the details. The details, we have about 74 errors coming out from the fact that they missed alt test. Now, this alt test is an attribute of the image tag. Let's check the image tag. HTML from W3C. You see, the alt text is actually, this alt text is what screen readers read back to persons who cannot see but are trying to use the screen reader to access your website. So if you do not enter any alt text, the screen reader will tell them the image, but they cannot know what image it is. So if we put an image of, let's say, an orange on the screen on our website, we need to give it an alt text like an orange, whereby the screen reader will read it back to the person who cannot see but is trying to visit your site as a picture of an orange or an image of an orange. Then it becomes easier for them to use your system, perceive your system, and understand it. From this report, we see that there are about 74 errors reporting on all tests where people using screen readers will actually find a lot of problems trying to understand. So let's check it out. Let's see what not adding an alt text will cause. So image alternative text is not present. Why it matters? Each image must have an alt attribute. Without alternative text, the content of an image will not be available to screen reader users or when the image is unavailable. So you see, not everyone who visits your website will have ability to see what is on the screen. Some come to your website only with a software which tells them what it is seeing on the site. And these people depend heavily on how you arrange your web content. So if your content is not well arranged, it becomes very difficult for them to understand or even gather information from your site. Let's check out the other errors. We have four missing form labels. That means they have created form inputs without labels. So it's very difficult for screen readers to know what that input is actually standing for. So why it matters that you need form labels? If a form control does not have a properly associated text label, the function or purpose of that form control may not be presented to the screen reader users. Form labels also provide visible descriptions and larger clickable targets for form controls. So you see that anytime I want to check a little information about the error that occurred, I click on this information icon, then it gives me details about that particular error. So that's something about the Wave 2. An interesting feature in the Wave 2 too is that, for instance, we can click on one of the errors for, for it to take us there, and we can click on code to view that the code, the section in code where that particular error is happening. For instance, when we click here, there is an error. We can simply click code, then it will take us to that particular section where that error is happening. So with this, you can actually scrutinize the website to understand what is going on and the necessary changes you have to do. So let's continue. Oh, sorry. Let's continue. The other error is that page refreshes or redirects. That means the page automatically refreshes or redirects to another place. Why does it matter that we check these things? Pages that automatically change location or refresh pose significant usability issues, particularly to screen reader and keyboard users. You see, just try to close your eyes and use only your screen reader to visit a website like this. If the website is not well structured, you will not get any information from the website. You see, if you have eyes, you can see that there's a lot of information here, but the person who cannot see any, cannot hear about any of this information. So we need to consider accessibility whenever we are designing to achieve our HCI goals. We have about 31 empty links. 31 empty links. They've put a lot of links on the page which are empty, which isn't going anywhere. Why does it matter? If a link contains no text, the function or purpose of the link will not be presented to the user. This can introduce confusion for keyboard and screen reader users. So you can imagine about 31 of these errors, which is very serious. We have about 26 contrast errors. Now, contrast has to do with how clear we can see content based on the background and the foreground of the content. For instance, if we create an HTML file with a background of black color and a foreground of, let's say, gray for text, it becomes difficult to see what you're talking. For instance, let's check this out. Advertisement. Advertisement looks like light gray on top of white. If you stand afar, it becomes very difficult to see this text on the screen. So we have to always check our contrast to make sure that people with low vision who cannot really see clearly and people who have color blindness and all those can still see text. Most of the time, the best is black text on white background. Mostly it works well for a lot of people with sight problems. So we have to always check our contrast. Then these alerts, possible alerts that they put on the page, we have 7 skipped heading levels. Uh, these alerts are things that you have to be alert on. Sorry, they are things that you have to check. They are trying to tell you that you have to check these things because it can also cause problems. So we have 7 times skipped heading level. You see, the screen readers follow the heading structure. We have the H1, H2, H3. So based on that structure, if you use H1, it sees it as the bigger heading, and when H2 follows H1, it sees it as a subheading. But if you begin with H2, then you bring H1 down there, it begins to cause confusion for the person who cannot see, who is trying to use the screen reader, because the screen reader assumes the H1 is actually the main heading of the page and the H3 is a subheading. Meanwhile, the H3 was the main heading and the H1 was actually the subheading. So we have to check all these things. With these errors, you see that a lot of things have happened. In my organization, Inclusive Tech Group, we were trying to build a news portal for persons who cannot see to use screen readers to actually gather information from the country, from the various media outlets. Now, let's take a look at that website and let's try to test out that website here to see if it is possible to achieve accessibility for persons with visual impairment if you follow the necessary guidelines. So this is actually the site we have, inews.inclusivetechgroup.org. When we visit this website, you realize that it is a very simple news site with despite son's marriage, Dwayne Johnson's, Dwayne Wade's, maybe Gabriel Union. If you follow basketball, you know these people. This was just a sample. This was just a test news for us to do actual user testing with people who cannot actually see. We contacted 7 people who cannot actually see to use their screen readers to check for information, and they gave us thumbs up that they can use their screen readers to gather information from here. You can also see that we have a tool up here where you can actually enlarge the text or decrease the text enlargement on the page. With this tool, it becomes easier to enlarge text and decrease text. So when you click on it, clicking the plus enlarges the text, clicking minus decreases the enlargement. Well, let's test to see if this site is actually accessible for persons with disability. You will simply copy the site link, go to Wave Report, change from My Joy Online to our website, then hit enter to start running the test. You realize that we have 0 errors, 0 contrast errors, and we have 6 alerts. That means things we have to also check to make sure that it won't cause problems. But you see, at the end of the day, you got congratulations, no errors were detected. Manual testing is still necessary to ensure compliance and optimal accessibility. So what we did is we followed the Web Content Accessibility Guidelines for web development. We call it the WCAG 2.0, which was developed by the W3C, World Wide Web Consortium. and it gives you some guidelines to follow when you are developing a website so that persons with disability will find it easy to navigate through your website. So if you check W3, WCAG 2.0, it will always bring you enough information and guidelines to follow in order to achieve your development aim. It seems you are having a bit of a network issue. Yes. Yes, but at least it seems you're having a bit of a network issue. At least when you check for WCAG 2.0 online, you can just Google to give you enough information on how to uh, develop a website in such a way that it becomes easier for persons with disability to use. Now, let's check the tools that we can use to also test for accessibility on Android. For instance, accessibility test Android. Let's see. So mostly I follow the Android documentation page to test for such information. You see, you have developer.android.com. When you go there, they'll give you enough information on accessibility test. See, they tell you that if you want to test accessibility of your Android app, you can do manual testing, which is you can use the talkback feature. The talkback feature is on every Android smartphone right now. All you have to do is go to your menu, your settings, check your accessibility, and then turn on the talkback feature, and your phone will start reading content back to you. It assumes that maybe you have visual impairment and it will start reading content back to you. You can also use a very interesting app, which I mentioned, known as the Accessibility Checker. Let me check from here. There is a lot of information here about possible ways you can test for your Android apps accessibility. But I'm trying to get you the simple tool to help you test your accessibility with ease. So let me check accessibility checker Play Store. Let's check on Play Store. You see, so it's called Accessibility Scanner actually. So with this app, it was developed by Google for you to test the accessibility on your website. Accessibility Scanner is a tool that suggests accessibility improvement for Android apps without requiring technical skills. Just open the app you want to scan, then tap the Accessibility Scanner button to find items in the app that might benefit from accessibility improvements. So all you have to do is simply install this app on your phone and open the app that you have developed that you want to test for accessibility. Then the app, you simply click on scan and the app will begin checking for accessibility and giving you a report on it. For iOS, you simply Google accessibility test for iOS, accessibility checker or accessibility test for iOS. And with this one, iOS, let's check the original, let's check the Apple website about accessibility verification on Android and on Apple app development. This page gives you enough information on how to test accessibility on your iOS mobile app. So this brings us to the end of this lesson. I hope that you have learned something about accessibility. It seems our WCAG, WCAG 2.0 is not opening. Just a moment. Let me try this link and see. Yes, so this is some Google hack. When you go online and you check, this is the guideline. Notice if you follow these guidelines, you end up definitely building a website which is very accessible for persons with disabilities. So I hope you have learned something about accessibilities. And I hope that you will put it to use to help people with disabilities. And I hope that you will also consider human computer interactions in your development process, because the more you do it, it makes life easier for people who have disabilities, and it makes life easier for your end users. This brings us to the end of the lesson. If you enjoyed the lesson, you can check me out on LinkedIn. This is my LinkedIn profile. There's my LinkedIn profile. You can check me out from there and leave a comment or just send me a message. Thank you for your time, and see you again.